Hello, everyone. Nice to meet you all. My name is Luis Loyola. I am the CTO of ALLM Corporation. ALLM is a health tech company from Japan, which is present in over 30 countries in the world. Today, I will be talking on future communication infrastructure and technical challenges in the medical field. First of all, let's see what communication platforms are good for in healthcare space. Well, communication platforms allow our clinical users to share patient information instantly and easily. They provide high communication security. They also provide high standards of patient data protection. They follow clinical protocols and workflows, and they allow our clinical users to integrate with electronic health record systems. Join is our communication application developed by ALLM, by our company. It provides a telemedicine platform for medical professionals. It is the first app registered as a medical device and listed in public health system in Japan. And it has a number of features. Some of them are very common or classical ones that you can also find in applications like Line or WhatsApp, like, for example, chat groups or notification, text messages, audio calls, video calls, right? But this one on the right side is a very distinctive one. This DICOM viewer is basically a feature that allow our clinical users to watch or visualize and share very easily all types of medical images, such as MRIs, CT scans, echography, etc. This DICOM viewer that you can see here is embedded in our Android and iOS application, and it allows our clinical users to see a very complex medical image, such as MRI or CT scan, which have a lot of slices. This is a basic diagram of the Join server architecture. So on one side, we have the mobile clients, iOS and Android apps, which communicate with this chat server in the middle, which is based on OpenFire technology. It has its own database, so its own tables. And the communication with the mobile clients, between the mobile clients and the chat server, is performed or done through XMPP protocol. The mobile clients, as well as the web client, communicate also with the REST server. Join REST is the name. This Join REST server is pointing to REST tables and also main tables related to user information, but also clinical cases and clinical protocol information. I will talk about that later. You can find this type of data in these tables are also transmitted to our clients through this REST API, right? And this communication between the mobile clients and the REST server is performed through the HTTP protocol. We have also a management console developed in C# in .NET framework, which is used by hospital administrators, which manage Join users in their organization. The communication between the management console and the chat server is done through HTTP protocol. And of course, the management console also needs to fetch user-related data and clinical-related data from main tables, as I explained before, through the HTTP protocol as well. So how do we do this DICOM integration, this medical image visualization in the mobile apps, right? How can we do it? So usually we install a server on the customer site called Join Gateway, which through a VPN is connected to a DICOM image server in our cloud. Our cloud is hosted in AWS, so we are using a lot of tools from AWS. And this image server, right, in turn, communicate with the chat and REST API server, right, to pass medical images, right, to the mobile clients, right? In the chat groups, for example, or in the clinical cases, you can also see DICOM images. And all this, of course, is done in a very secure way through this SSL TLS with 256 bits. There is a growing need for communication platforms in healthcare. Why? First of all, because there is an increase in patient volume due to aging population. We know very well about this in Japan, right? The communication platforms also need to follow the advancements in technology, right? such as telemedicine, EHR systems, and also mobile health apps. Communication platforms can provide also or offer our users cost savings. How? With less face-to-face visits, and also through the streamline of administrative tasks that usually take a lot of time. They're very time-consuming. Communication platforms also increase the quality of care by allowing healthcare providers to collaborate more effectively, and also by providing patients with timely and accurate information. Communication platforms also increase patient engagement through easy access to information and resources, right? So that the patients can become more engaged in their own health and also improve their overall health outcome. Communication platform also provide better remote care, right? And we could see very clearly this during the pandemic. And last but not least, through technologies like ChatGPT with these AI chatbots, right? Basically, they set a standard that communication platforms need to fulfill as well. So overall, communication platforms have the potential to improve the efficiency, effectiveness, and accessibility of healthcare, which is why their usage is increasing. We have another very distinctive feature in Join, which is that we can preload clinical protocol, for example, heart attack protocol, clinical protocol, or brain stroke clinical protocol, and other ones, such as, for example, diabetes and other ones. These protocols have steps, are divided in steps, right? And these steps correspond to clinical procedures, right? So basically, a protocol consists or comprises several steps or clinical procedures which are applied on a patient, right? So basically, the users of Join, which are clinical users, doctors, right? For example, in an emergency room, don't have time, right? Usually just attending the patient, they need to be focusing, right, on the patient. So they don't have much time to start typing messages and so on. So these clinical protocols become very handy because they can, with one click, they can mark the date time in which each clinical procedure is performed, right? And this is done through these timestamps, right? So why are these timestamps very useful? Well, later on, right, after the protocol has been, or the different procedures have been marked with timestamps, you can, or the hospitals or users can analyze the monthly data, yearly data, and see, for example, how much time each step is taking, right? So if some procedure in particular is taking too long, right, which can be very problematic for acute diseases such as a heart attack or brain stroke, if it's taking too long, right, the medical director, for example, know which action to take, right, or with which team he should talk to in order to improve that situation, in order to reduce that time, right, that is taking too long. So we are currently working with several institutions all over the world and with several clinical protocols with these timestamps. These are some examples I was mentioning: brain stroke, heart attack, but we are also working with several protocols related with emergency networks and also diabetes. Another interesting topic is the possibility of integrating Join and also other platforms with IoT sensors, right? So IoT sensors such as blood pressure monitors, eye fundus cameras, glycemic measurement monitors, electrocardiogram monitors, EEG monitors, etc., can be connected with electronic health record systems such as HumanBridge or TrackCare, with personal health record apps such as MySOS, developed by our company ALLM, or also with doctor-to-doctor communication apps such as our application Join, right? So all this data, this very valuable data coming from IoT sensors, can be shared by different systems using this system called Patient Folder, which is basically a clinical data storage and sharing system, which is compatible with FHIR. And you may ask, what is FHIR? Well, FHIR stands for Fast Healthcare Interoperability Resources, and is a RESTful API for exchanging health or clinical data. It was created by the group HL7. This HL7 group has a long history. They released the HL7 version 2, which is still used today, they released this protocol in 1989, but version 2 of HL7 was mainly for internal hospital data exchange. So they released HL7 version 3 in 2003. This was for health information exchange between hospitals or among several hospitals, but unfortunately it was too complex and was not really much adopted, right? So because of its complexity. So 2 years later, in 2005, the same HL7 group released this clinical document architecture, which is basically a simplified HL7 version 3, right? And this is widely used even today. In Japan, it's also very much adopted in many clinics and hospitals. And finally, the same group, HL7, released in 2014, FIRE, right? Which is basically a simplified REST implementation of CDA, which leverages RESTful web services and modern open web technologies such as XML, JSON, and RDF. Let me talk a little bit about our current R&D projects related with Join, with this communication platform. So we are working in several topics, but mainly on these 4 topics currently. The first one is automated clinical trial matching using artificial intelligence. The second one is alert notifications based on patient health data for PHR applications like MySOS. The third one is AI chatbots. And the fourth one, automated text tagging using natural language processing. Today, I will be talking mainly about these latter 2, the chatbots and also the automated text tagging. But I will briefly describe the first 2 in the next slides. So the first topic was automated clinical matching using machine learning. In ALLM, we have developed this clinical trial enrollment application named Enroll, right? So what is the idea here? The idea here is to come up with some, or basically have some eligibility criteria for the patients, right? Connect this to a deep learning model, which extract features from patient data. And this extraction of features, right, can work as a filter in this patient database so that we can calculate a patient matching score. If the matching score is above certain threshold, right, we can say, right, or communicate to our customers that this patient is eligible for a clinical trial, right? So why is this system useful? Well, because it saves time to recruit patients, which is very time consuming in the case of clinical trials. It mitigates adverse events. The matching is highly reliable because it has a very high accuracy. And also there is a reduction of risk identification, right? So for all these reasons, this system is very useful. The second R&D topic or research topic we are currently working on has to do with the alert notifications based on personal health record data. So this is another of our applications developed in ALLM. It is called MySOS. You may know it because it was very much used during the pandemic. To enter in Japan, you needed to download this application. So if some of you traveled during that time, you must know it. So from MySOS, we obtain patient health data, right? We connect again to some deep learning model. And as in the last slide, we also extract features from this patient data, right? And these features become, or this model, right, become a filtering in our patient database. So we can calculate a health score per patient, right? And send our user or patient, right, personalized alerts, warnings, or recommendations, right? So why is this research topic good or useful for? Well, we can do predictive analytics, right? So basically calculate the likelihood of developing a particular disease or the risk of a health complication for this patient. And we can recommend the patient to visit the doctor or some specialist, right? Or even recommend while visiting the doctor to go, right, to take some exams, right? This exam may be needed. We can say that to the patient, right? We can also recommend some lifestyle, give some lifestyle advices to our patients or to our users. And all this is extremely valuable from the user point of view, right? So this is the second topic. And now I will talk a little bit more on what we are working on in the chatbots space. So chatbots are useful because they allow us to do several things. For example, triaging patients, providing information about condition, treatment options, and recovery to patients, right? We can they can also schedule appointments on behalf of patients. They can help our patients to manage their medication, right? They can also allow us to do a follow-up care to our patients. They can also provide remote consultation with healthcare providers, so especially in rural or underserved areas, right, through telemedicine. This can be very useful. And even for research, chatbots can be used to aid in clinical research by gathering data from patients and providing personalized information based on that data. Overall, chatbots can be a valuable tool in clinical communication systems, as they can improve efficiency, reduce costs, and enhance the patient experience. So we have developed in our office in Europe a chatbot called Jacob. And why Jacob is needed? Well, the status quo is that every hospital has different workflow, right? Every change in the Join application applies to all users and hospitals, right? But not every hospital may want a specific feature. So another problem is that, of course, new features in Join, which is already a big platform, need to be implemented in several platforms and also on the server side, and this requires a lot of resources and time. So Jacob is a very small server. It's a Docker container that requires just a few lines of code that uses the existing Join API to access information shared with the Join user. So what can this bot do? Well, this bot can listen to new messages, upload the icons, etc., and as a trigger, right? And given that, it can send a message, it can automatically create a case, it can automatically send the timestamps to, for example, a clinical protocol. It can transfer information to other platforms, like, for example, a health information system, some external system, right? And this even works with end-to-end encryption. So let me give you some examples, right? So example number one, we have an application called Join Triage, which is to perform scales on, for example, a brain stroke patient suspect, right? So the scale is performed, and after we obtain a score, we show in Join Triage the closest hospitals where we can transfer this patient, right? So all this information is automatically transferred from Join Triage to Join. That's already done. But we are also, on Join side, creating a new case following the brain stroke protocol that I was talking before, I was describing before, so that we can create, from the Join Triage message, we can create a new case of brain stroke protocol in Join, right? So users don't need to enter information twice. The chatbot listens for Join Triage messages and creates a new case with all the information provided by the message. This is very handy, very useful, because our clinical users don't have time. They need to allocate time to the patient, right? Not to be typing on their mobile phones or on a PC. So another example of Jacob is real-time statistics of intensive care beds. So this is, again, from the European office. So the chatbot extracts information from DB, which is the German Intensive Bed Registry website, and posts it in a certain chat group, right? Every few minutes, right? So why this is useful? Because, again, physicians don't have time, and they don't need to be actively looking up the info, but just being aware, right, of the chat group. They can receive the notification that some change happened in this intensive bed registry, and this can be published in the chat group, and for them it's very convenient to see it there, right, and not to be checking the website very frequently. Another example, sorry, is the integration with the health information system. So emergency registers patients in a system called IVENA, or IVENA Health, which is a web-based system to send emergency services in Germany and Austria. So basically, our bot polls new patients every a few seconds. If it detects that a new stroke patient case has been registered, right, it sends the corresponding message to the chat group in Join. So it also creates automatically a join case for that patient. And for every update in that case, it also sent the timestamps, so update the case in Join. So basically, this also saves a lot of time for the clinicians. And it can even send CSV files to the Ministry of Health, right, for further analysis. Of course, these doctors use these CSV files or PDFs or whatever format they want for review and research of different clinical cases. So basically, the system is described in this slide. And here you can see how the bot, right, send the information in the target group, how it creates automatically a case, right, and how we even, well, it's not shown here specifically, but the bot can update this case with new timestamps, right, that are coming from the centralized database, right, from the government. Another example is patient recruiting for clinical trials. And this is related to the slide I was talking before, right, with Enroll. So basically, we have some apps for clinical trials, right, like Enroll in Japan. In Europe, we have an application developed also by the European team called Joint Trials. So upon the fulfillment of a basic matching criteria, the chatbot asks the clinicians further questions in order to figure out whether that specific patient is a good candidate or not for clinical trial. So frequently, the recruiting of patients are randomized and distributed into two groups, the ones who receive the active treatment and the other ones who receive the placebo. The digitalization of this process, right, using this chatbot, helps specialists save their valuable time and make the enrollment process much smoother. So after the patient is selected, our chatbot Jacob continues asking further questions during the active treatment in order to provide relevant follow-up information to the doctors and specialists. Another example of the possible use of chatbots like Jacob is customer support and sales boosting. As you know, ChatGPT or Google Bard are going to become a commodity, most likely in a few years' time. So we can use these bots, right, for product and commercial purposes, and basically answering inquiries by customers, responding to complaints by customers, or even introducing new products or services to our current customers, right? This can be a very, very powerful tool for commercial teams. And this applies not only for our case or the healthcare industry, but in all industries. Let me talk about this another research topic that we are working on since recently, which is automated text tagging using natural language processing. So basically, as you know, as I described before, Join is like Line or WhatsApp, right? So our users can basically send text messages with free text, right? Unstructured text. So using natural language processing tools, right? With text analytics, right? We can basically detect from this unstructured text, detect structures that are related with very valuable clinical information. Let me explain. For example, well, this is text in Spanish, just as an example. It works in all languages. So, for example, from this free text, right, in the case of a brain stroke patient, we can see that this doctor here in this chat group is making a clinical indication. So from this unstructured text, right, we can deduce that there was a clinical indication, and this can be sent to, right, Join or some external electronic health record system through FHIR, for example, right? We can also detect, for example, that there was a clinical case presentation, right? These are all structures that are defined in FHIR. Okay, so they are defined for clinical data exchange. So if we can say, okay, from this free text, I can deduce this is a clinical indication. From this free text, that this is a clinical case presentation, right? We can send these tags, right, to Join or electronic health record system, store them there, and then analyze how many cases were presented last month, for example, of brain stroke or heart attack or diabetes. How many clinical indications related to such and such disease were presented in this hospital last week, for example. We can start answering all these type of questions, which are very interesting, right? Interesting from the point of view of data analytics. We have many more examples. For example, we can, in this case, an image, CT scan, right? A head CT scan was shared in the chat group, and we can deduce that the text that is coming after that is a medical image interpretation, right? This can also be very valuable. For example, how much time transcur or pass between sharing the CT scan and getting the image interpretation, right? That's very important for acute diseases such as brain stroke or heart attack. Or, for example, deduce that this is a clinical procedure, right? Or a clinical indication, right? So all these FHIR objects or FHIR compatible structures, right, become valuable information, right, for data analytics. And why this data analytics is useful, of course, to improve or enhance the execution of clinical protocols in every hospital, right? So this automated tagging from free text into FHIR structures or FHIR objects can become very, very powerful for data analytics. So we are very interested in working on this topic. If you have any new ideas or new tools we can work with, please let me know. We are currently testing Amazon Enhance and also ChatGPT and other tools, other NLP tools. But if you're interested in this topic and collaborating with us, please let us know. So, as conclusions, communication platforms for clinical use are becoming increasingly important as healthcare organizations move towards more digitized and connected systems. Functionalities and tools based on natural language processing and artificial intelligence will play a significant role in their user adoption and interoperability during the next coming years. Connection with IoT devices, AI-powered image analytics, and EHR systems will also be highly relevant to create powerful tech ecosystems in healthcare. Other big challenges not covered in this presentation are data security and privacy, as well as compliance with local and global regulations, which of course are very important in the healthcare industry. Overall, clinical communication platforms have the potential to significantly improve patient care and streamline healthcare operations. Well, that's all what I have for today. Arigato gozaimasu. Gracias, as we say in Spanish. Thank you very much. It was a pleasure. Here you have my email address in case of inquiries or comments or any new ideas for new research topics. Please contact me. So thank you very much for your attention and see you soon. Bye-bye.